Something impossible just happened. And by impossible, I mean scientists looked at the data 3 times, checked their math, argued about it in conference rooms, and still came back with the same answer. The James Webb Space Telescope has found a black hole that existed before its own galaxy, not just before its galaxy matured, before its galaxy existed at all. And according to everything we currently know about the universe, that simply cannot happen. So let's talk about why this discovery is either the most exciting thing in modern astronomy or the beginning of a very uncomfortable rewrite of physics. A black hole forming before its galaxy is a bit like finding a city that was built around a single house that somehow appeared before the land it sits on. Our entire model of cosmic evolution assumes that galaxies come first. Gas clouds collapse, stars form, the biggest stars explode or collapse into black holes, and over billions of years those black holes grow by consuming surrounding matter. The supermassive black holes sitting at the centers of galaxies today, including the one at the center of our own Milky Way, are understood to be the products of long, slow cosmic cooking. But Webb is seeing something that breaks that recipe entirely. The black hole in question, detected in a galaxy from the very early universe, appears to be nearly as massive as the galaxy surrounding it. In a normal galaxy, the central black hole accounts for about a fraction of a percent of the total mass. Here, we're potentially looking at a ratio that is orders of magnitude higher. The black hole isn't a small seed that grew inside a galaxy. It looks more like the galaxy grew around the black hole. Now, here is where things get truly strange. Some of the theoretical models trying to explain this are pointing to an origin, not just early in the universe, but almost incomprehensibly early. We're talking about the first second after the Big Bang. The universe at that moment was not a place with stars or galaxies or even atoms. It was an unimaginably hot, dense soup of fundamental particles, energy, and chaos. So how does a black hole form in that environment? One hypothesis is what scientists call primordial black holes. The idea is that in those first fractions of a second, quantum fluctuations in the density of the universe could have been extreme enough to create regions where matter collapsed directly into black holes without any star formation required. No star needed, no galaxy needed, just raw energy and gravity doing something extraordinary in the earliest moments of time. These primordial black holes have been theorized for decades, but they've always been a bit of an exotic, fringe idea. Webb might be giving them their moment. Another explanation involves what are called direct collapse black holes. Instead of a star forming and then dying into a black hole, this model suggests that under the right early universe conditions, enormous clouds of hydrogen gas could have bypassed star formation entirely and collapsed directly into a massive black hole in one dramatic event. Think of it as skipping several steps in the normal recipe and jumping straight to the end result. Either way, what Webb is showing us is that something in our model is incomplete. The universe was apparently making supermassive black holes far faster and far earlier than our simulations predict is possible. And this isn't just one observation. Webb has now identified multiple galaxies in the early universe where the black holes are disproportionately large compared to the host galaxy. This is starting to look like a pattern, and patterns in science are always meaningful. What makes this especially significant is what it implies about galaxy formation itself. If black holes came first, then supermassive black holes may not be a byproduct of galaxies. They might be the seeds that galaxies grew around. Gravity from these early black holes could have been the anchor point that pulled in gas, triggered star formation, and sculpted the large-scale structure of the universe we see today. That would flip the causal relationship we've assumed for decades completely on its head. It's also worth noting what this means for dark matter research. Some theorists have proposed that primordial black holes could actually account for a portion of dark matter, the mysterious substance that makes up roughly 27% of the universe's total mass energy, but has never been directly detected. If Webb is confirming that primordial black holes are real and formed in large numbers in the early universe, it reopens this avenue of investigation in a serious way. Now, scientists are careful. They're not declaring the textbooks wrong just yet. There are alternative explanations being considered. Some researchers suggest that the measurements might be affected by the extreme distance involved, since we're looking at light that traveled over 13 billion years to reach us. Gravitational lensing from intervening matter could potentially amplify what we're seeing. Calibration issues with how we estimate black hole masses in such distant and ancient objects are also being scrutinized. But the fact that multiple independent observations are converging on the same unsettling conclusion is hard to dismiss. This is what makes the James Webb Space Telescope so remarkable and so disruptive. It wasn't supposed to just confirm what we already knew. It was built to see further and deeper than any telescope before it, and in doing so, it has repeatedly shown us that the early universe did not behave the way our models said it should. Webb has already shaken up our understanding of how quickly the first galaxies formed, how large they were, and how structured they appeared at remarkably early times. This black hole discovery is the latest and perhaps most dramatic challenge yet. Science doesn't collapse when it finds something it can't explain. It expands. New data forces new thinking, and new thinking leads to better models that make better predictions. What we're witnessing right now is that process happening in real time. The universe is revealing that its earliest moments were more violent, more productive, and more strange than we imagined. And somewhere in that strangeness might be the answers to some of the deepest questions we've ever asked. Where did everything come from? What came first? How does gravity shape the largest structures in existence? We don't have all the answers yet, but thanks to a telescope orbiting 1,000,000 miles from Earth, we are finally asking better questions. And in science, that is always the beginning of something extraordinary.